Hello viewers, third update on LED Matrix message scrolling board. It's been a while and several things happened to the project. There were hardware and firmware and host application upgrades. So let's start with the hardware here. Well, I ran out of program memory. So if you remember, I used AT89S52 microcontroller, AT52 compatible from Atmel, which had 8 kilobytes onboard flash EPROM program memory. And as I was adding features to the firmware, I ran out of that space. So first I thought I would just buy a chip with bigger memory, and I purchased also Atmel's chip, AT89S 8253, I believe, which has 12 kilobytes of program flash memory, flash EPROM. However, when it arrived, I realized I don't have a programmer for it. I didn't want to waste any time building a programmer or spending extra $25 just for this one chip to buy a Willem programmer adapter to be able to program it. So I decided I'll just use external program memory, and my vote was for flash EPROM from Intel, 32 kilobytes. It's right here. Very easy to program, 100,000 write cycles, easy to program and erase. So that's the advantage over the standard UV erasable chip. And so it is. I have now 32 kilobytes of program memory, lots of space for any features I would like to add. Another hardware upgrade is a work in progress. I started to build a PCB for the permanent project solution, let's say. I currently just laid out the IC sockets, the LED matrix connector, voltage regulator with the heat dissipator, and I soldered in the power lines. I'm going to use point-to-point soldering technique because this application will be used in the shaking and vibrating moving car, so it has to withstand all of that shaking and vibrating, and connections should not come loose. So that's it. As hardware goes, now the software. The software received very interesting upgrades. And one of them, the most important one, is the scripting engine. I added the plain text script interpreter to the firmware, so user now can send actually the program written in the language that I designed, which will allow the programmer to customize each of the message to be presented on this LED matrix board separately. So, for example, programmer might decide that one message will be displayed statically while the other one will be scrolled. They can be scrolled at different speed, they can be displayed at different time intervals, so it added great flexibility to the application. It's I think it's a great addition, and I'm this also lets the user to program add some special effects like letters appearing sequentially on the display, or displaying static text and then starting scrolling it. But enough speaking about it. The example speaks best, so let me demonstrate. I will just start now the host application, which lets the user control this. All of those features. Okay, let board. So currently the controller is in the default mode. After the power up, I'll just reset it right now. So you could see it's reset. It displays some generic message that's hard-coded in the program memory. And the host application, once started and connected by serial port to the controller, will switch the controller to the clock mode, first sending the script terminating command just in case if script is executing, because during the script execution the responsiveness of the microcontroller is somewhat limited. It only will react to the script terminating command. So this is it. And let me demonstrate the script management functionality here. I will select just another script here, the demo script that uses most, if not all, of the features that I have in this homebrew designed language. As you can see, the script is kind of similar to basic syntax. It's very limited. Takes just one instruction per line. It supports goto and goto subroutine. It does not support nesting, so there are no nested loops, but there are loops. You can use the repeat loop. There is no support for variables, just the parameters and static scripts added, provided as arguments to the instructions. But it's at this level very practical and usable. Let me demonstrate by sending this first simple script to the controller, which will scroll several messages, display some of them, statically blink them, scroll again, display clock, and such. It is very simple. Just click upload the script, transmission starts, controller goes into the script mode, and now the script is being uploaded to the controller. And if there are no errors during transmission, the script will start executing immediately after the transmission is over, which is the case. So transmission is done, script is executing. Let me display the code of the script again so you could see. The commands currently executed. So this is SCRL instruction. which simply says scroll this text with certain properties provided here as arguments. Now it scrolls the second one, warning nerd on board. This one is pretty simple. The next command that will execute is PRN, which is static display, and then I call the blinking subroutine, which simply turns on and off display several times. And then there is a series of static messages that form a full sentence, that they are displayed in a sequence. Each part fits into this 16 characters display, and this is basically it. This is how it works. I also have on the board of this new Atmel controller that I use 2 kilobytes of non-volatile memory. This is EEPROM. It is accessible from the programming level, and I already use it for saving some basic parameters. So when I click this button here in the host application, store setup on chip, it will save some of the parameters like scrolling speed, brightness, scrolling smoothness, and delay between the text index change. It will the program will store them in that EEPROM memory, and during the next reset or power up, these parameters will be read from that memory at the program startup, and they will be used. I am going to use that memory to the limit, perhaps store some kind of startup script in that memory, so there will be no need to actually connect the host application to the controller each time I power it up, because it will display customized messages that I uploaded during the last session, and I can use them for whatever time period I feel suited, and just use the host application the next time I want to change the customized messages. So as you can see, the project goes forward. It is still in prototyping stage, but I'm getting closer. Thank you for watching.